So today we're doing sum and difference of two perfect cubes in this case. So what I want you guys to do is just do now A, B, C, and D. Pause the video and play it once you're done, and I'll show you the answers. Here's what I got for A, B, C, and D. For A, pretty straightforward, difference of two perfect squares there. For B, make sure the second one is another difference of two perfect squares. Once you factor the first difference of two perfect squares, so you have to factor one more time. Look at C. Why is that not factorable? It's because it's in sum of two perfect squares. We only factor difference of two perfect squares, so it has to be subtraction. And then D is similar to B. The x to the 6th, y to the 10th minus 1 is a difference of two perfect squares because both the exponents are even and one's a perfect square, so we can factor that one more step. So let's go to the next page. So instead of just factoring difference of two perfect squares, now we're going to factor two perfect cubes. And with cubes, they can be sums or they can be differences. So it's not just, you don't only factor the difference of two perfect cubes, you can also do the sum of two perfect cubes. And here are the formulas. So just take a second, look at them, see like, okay, is there an easy way to kind of memorize these formulas? I'll tell you what I do. So the biggest thing I think you need to memorize is just the order is always the same. There's A, then B, A squared, AB, B squared. So once you get the order of that down, it's pretty easy from there. And then if you look at the sum, the first sign is always the same. Plus, when you look at the difference, the first sign is always the same. And then what changes is the second sign. So the second sign is always the opposite sign of what the original expression was. So if it's the difference, then we have a plus sign for the second sign. And if it's adding, we have a subtracting sign for the second sign. And then it's always a plus to end out things. So let's do an example, and I'll kind of show you like the work I do to make it a little bit easier. And whenever I learn like a new formula, I always think it's best to like write it out every time you're going to use it, because then you memorize it a little bit better. So if I'm going to completely factor x to the third plus 8, I know that's a sum of two perfect squares because I'm adding. So I'm just going to write out the formula here. A to the third plus b to the third equals a plus b. We're using this one right here. Times a squared minus a times b plus b squared. Now, what I like to do is I like to actually say what my A and my B are going to be, because then I can just kind of like turn off the brain and plug in. So if A to the third is x to the third, if I cube root x to the third, I get x. So A would be x. And I do the same thing to 8, cube root of 8, and I get B, which is 2. And now I can just plug that in for A and B. So I have A is x, B is 2. Keep going. A squared would be x squared minus A times B would just be 2 times x, or 2x, plus B squared, which is 2 squared, which is 4. And that's literally all you need to do. Make sure it's not, you can't factor anymore. X plus 2 can't factor. X squared minus 2x plus 4 can't factor anymore. So I'm done. And I'm going to literally do the same exact thing for the second one. But in this case, it's a difference of two perfect cubes. So I'm going to use the difference of two perfect cubes formula. I'm just going to write it down because I think it's easier to memorize if you write it down every single time. And try not to look, try and like be like, okay, I think I know what it is without looking, a little bit above. So A minus B, keep the same sign. That's always A squared. Change the sign, plus A times B. That's always a plus there. And B squared. So to find A and B, I just take the cube root of A to the third. Cube root of A to the third is A. So A is A. And then you do the same thing, cube root of 125. You don't do negative 125. I know a lot of students think they do. You just do 125. We deal with the signs like inside of the actual like factoring. So you just do the cube root of 125, and that would be 5. And now I can just plug in for a and b into my actual formula. So a is lowercase a, b is 5. A squared is lowercase a squared. A times b is 5 times a, so it'll be 5a. Plus b squared, which is 25. Make sure your signs are all correct. That's an easy place to make a mistake. Make sure nothing else can be factored. It can't be. That is my answer. How about, I want you guys to try the next two. Pause the video and play it when you're done. So these, you're doing the same exact thing for these two. So if I want to find what a is going to be, and I want to find what b is going to be, I just take the cube root of 27x to the third and the cube root of 64. So b should be 4 and a should be 3x. So when I plug that into our equation, we're using the difference of two perfect cubes. We should get 3x, keep the same sign, minus 4. And then a squared, which would be 3x squared. I'm going to show a little bit extra work. You might not have showed this much work. I'm doing this for a reason. I'll show you in a second. Then plus, opposite sign, a times b plus b squared, which is 16. So make sure you simplify from here. You might have done it all in one step. That's fine. So the 3x minus 4 stays 3x minus 4. 3x squared, I see a lot of people, 3x squared, I see a lot of people say is 3x squared. That's not the case. You forgot to square the 3 as well, because technically it's 3x times 3x. So this should be 9x squared, then 3x times 4 is 12x plus 16. I find if you do that, like plugging in like that, you're less likely to make a mistake of doing the 3, just writing 3x squared. Just make sure you can't factor that anymore. You can't. So that would be the correct answer. And last one for a, well, the cube root of x to the 6th and the cube root of 216. So a would be x squared and b would be 6. So if you want to write out the equation again, a squared minus a times b plus b squared. That's what we're going to be using. So I can plug in for a, I can plug in for b. So a is x squared, b is 6. A squared would be x squared squared, which would be x to the 4th. You could also write it out as x squared squared, power to a power you multiply, so that's why it's x to the 4th, times a times b, so that would be minus 6x squared plus 36. Careful with the I still make mistakes sometimes with the signs because I don't check them and I sometimes mess up the signs. So make sure it's at the end. Make sure everything's factored, and make sure that the signs are all correct. Those are the biggest two mistakes I see. Let's go to the next page. So the next two are slightly different. You may not see how they're different yet, but they are slightly different. Actually, you know what? I want you to try the first one. Pause the video, play it once you're done, or if you have a question, and we're going to go over it. So the first one, this is still a difference of two perfect cubes because x to the 9th is a perfect cube. The exponent's a multiple of 3. And 1 is a perfect cube, 1 times 1 times 1. So we can do a minus b, a squared, plus ab, plus b squared. So when I do this, well, if this is a to the 3rd minus b to the 3rd, then my a is going to be cube root. My a is going to be x to the 3rd, and my b is going to be nice, it's 1. So when I plug in for a and b, I will get x to the 3rd minus 1 times a squared would be x to the 6th, a times b plus x to the third, b squared plus 1. And if you circle your answer here, you would be incorrect because you always want to make sure, well, obviously make sure the signs are okay, they are, but you also need to make sure, can we factor anymore? And yes, we can. Look at the first factor, x to the third minus 1. What is that? That is another difference of two perfect cubes. So what we need to do again is do the same thing. So in this case, a is now x, b is now 1 still. And now I can factor that first factor one more time. So now this would be x minus 1 and a squared plus 8 times b plus b squared. So that's how you would factor x to the third minus 1. And then don't forget this last factor. I see a lot of people forget to write like the factor that we weren't factoring anymore. But make sure you write that last factor. And this would be our correct answer. We can't factor that anymore. You should try to factor it, but you can't. And that's our answer. I also want you guys to try that second one. Pause the video, play it once you're done, or if you have a question. So how is this second one a little bit different than the other ones we've been doing? Don't forget the first rule of factoring always. Never forget it or else you won't be able to actually factor this. Take out a GCF. So if there's a GCF, take it out. There's a GCF of 3 here. So if we take out a 3, we have x to the 9th plus 8. And now we can see, oh, this is a sum of two perfect cubes. So now I could write, okay, so a is x to the third, b is 2. And now I can just plug that into my sum of two perfect cubes equation. So that would be same sign. And then that would be a squared, so x to the 6th. You change the sign, a times b plus b squared, which is 4. Check it. Could I factor this anymore? No, I can't. So that would be my answer. Make sure, I see this mistake a lot. People forget to write the GCF with their answer. So make sure you write the GCF with your answer. That's it. I want you guys to try to checkpoint. So, pause the video, take your time, play the video once you're done, and we can go over the checkpoint. And here's what I got for the checkpoint. Let me see here. Any common mistakes here? I think the biggest mistake is, if we have two negative numbers here, we want to take out -6 because that's going to make it a lot easier on us. I guess you technically don't have to. You could take out a +6, but I think it's going to make it a lot difficult on you. So take out a -6. It's going to make it way easier. It's going to make them both positive, and then you can do the sum of two perfect cubes from there. 3 also has a GCF. Make sure you take out that GCF. And look to factor it. This looks like you could potentially factor it. You can't. But that's it. Let's go to the next page. So looking at the next page, I think this is more difficult to see. What is different about this question than every other question we've done? If I want to completely factor this expression. This is a tough one to see. So this is a difference of two perfect cubes because 64 is a perfect cube because the cube root of 64 is 4. The cube root of x to the 18th is x to the 6th, and the cube root of 1 is 1. So this is a difference of two perfect cubes. But what is it also? It's also a difference of two perfect squares because square root of 64 is 8. Square root of x to the 18th is x to the 9th, and the square root of 1 is 1. So it's both a difference of two perfect squares and a difference of two perfect cubes. But one of those ways, you're going to want to start off one of those ways because it's going to make it more factored, more simplified at the end. So this is what I want you guys to do. On the left side of this, I want you to factor using, let's do difference of two perfect cubes first. So do that step first. And on the way on the right, let's do difference of two perfect squares first. and then keep going and see what you can do to simplify each side. There is one side that's going to be a little bit more factored, and that's what we're going to want to go with. So try that out, pause the video, play it once you're done, and we'll go over it. So this is what you should have gotten for here I did the cubes first. Here I did perfect squares first. Which one's more simplified? Which one would you want to circle? You would want to do the difference of two perfect squares. We have 4 factors there, as opposed to only 3 factors with difference of two perfect cubes. So you want to always do difference of two perfect squares first, because that's going to simplify and get you more factors first. You actually could do difference of two perfect cubes and factor this. This is, I think it's going to be factorable. You would just have to use like a different form of factoring. That's really not factoring, it's dividing. We're going to do that in like 3 units. It's going to make the question way more difficult and way more work. So I would never do factoring a difference of two perfect cubes first, if it's also a difference of two perfect squares, because it's so much easier to do difference of two perfect squares first, and then do difference of two perfect cubes if you need to, or sum of two perfect cubes. So always do squares first, and then if you have to, do the difference of two perfect cubes after. You could do all of the squares. So I just want you guys to do the next question. This is what I got for my answer. It is a bit of a lengthy answer. So you first want to do difference of two perfect squares, because they are squares and they're cubes, but do perfect squares first. And then each of these are also a difference of two perfect cubes, and difference of two perfect cubes, and also difference of sum of two perfect cubes. So you can keep on going from there. But then when you keep on going from there, they also split up into a different sum of two perfect cubes and difference. Sum of two perfect cubes and difference of two perfect cubes. So you got to do that one more time. So this is the completely factored form. That's it. If you're done, feel free to work on the homework. And this is the last question. It's similar to the one above. But this is the last question of the notes. Pause the video, play it once you're done.